Alrighty, happy Thursday, everybody. Um, we are going to continue our discussion about nomenclature. Even if I'm not there with you, you can still actually get a live lecture and fill in your notes. So the same sheet that you used yesterday, make sure that you're completing your notes for covalent nomenclature today. Covalent nomenclature, I think, is a lot easier than ionic. So hopefully you'll be able to follow along. And then tomorrow I'll answer any questions that you guys have about covalent nomenclature after you try some on your own. Okay. So the first thing that, and again, I always want to remind you of is when we are dealing with naming nomenclature, we want to make sure we understand what the formula is telling us. So again, a formula tells us the elements that are involved, and it tells us how many of each of those elements are involved. That's called a subscript. So the subscript tells us the number of the elements that are in, and it always represents the element that's right in front of it. So in this case, H is our symbol for hydrogen, and this 2 tells us that there's 2 hydrogens for 1 molecule of H2O. Remember, if there's no one or no number here, it represents a 1. So 2 hydrogens and 1 oxygen. And these are subscripts. It tells us how many atoms are involved in the bond. Okay? All right. So yesterday we talked about binary ionic compounds. And today we're going to talk about binary covalent. So as a reminder, covalent compounds are compounds between 2 nonmetals. Binary just means 2. Now, the thing with binary covalent compounds is sometimes they can form many different pairs with the same 2 elements. Ionic doesn't really do that. Ionic, you can only bond one way because they have a set oxidation number. Covalent doesn't really operate that way. They can share several different bonds in several different ways. So 2 of the same elements could actually make several different compounds. For example, let me move my face over here. Oh, I made my face big. All right, let me move my over here. So nitrogen and oxygen are 2 nonmetals, and they can bond covalently to form the molecules NO, N2O, NO2, N2O5. All of these deal with nitrogen and oxygen. And if we were using the same rules as ionic, they would all be called nitrogen oxide, but they're all different. So that would be like me calling all of you Nancy. That's not right. You guys don't all have the same name because you're all different people. So that's why covalent compounds need a different set of rules to identify their compounds. So we're going to start by learning how to read the names or write the names, and then we're going to learn the formulas. The first thing you're going to need to know when we're dealing with covalent compounds is you need to be aware that we are dealing with prefixes. The prefixes that we're using for covalent are going to be the Greek prefixes. And prefixes come before the element name, and they indicate how many atoms of each element they are in a covalent compound. So here are the prefixes that we use, and it tells us how many of each element are there. So if it says mono or monoxide, that means it has 1. Di means 2, like diagonal. Tri is 3, like tricycle means 3. Tetra is 4. Penta, 5, like pentagon. Hexa is 6. Hepta means 7. Octa, like octagon, means 8. Nona means 9. And deca means 10. So these are the prefixes that we're going to be using to identify how many atoms there are in our compound. Okay? So we're going to keep that chart handy as we go through these. So let's take a look at writing our names first. So just like ionic, I have to give you a formula. And whatever formula I give you, whatever I put first, that's what you're naming first. But if you want to get technical, it is going to be the least negative element first. In ionic, it's always the positive first. Covalent are both negative, so you're just going to name the least negative. But whatever I name or whatever I give you first, name that one first. Okay. Same rules as ionic. You'll name the second root name of the element, and then add IDE to the end. So just like ionic, you're going to end with IDE. Okay. This part's a little bit different though. Instead of just leaving it as first name, last name, IDE, then we have to go through and add our prefixes so that we identify the different compounds and not just call them all Nancy, okay? So let's use the example of H2O. So H we know is hydrogen. That's my step 1. Step 2 is oxygen, but I have to use the root name. So oxa, and then we use ide, oxide, okay? So I can't just name it hydrogen oxide. That's not fully correct. I now have to add my prefixes. Since H2O, the 2 represents hydrogen, I'm going to put the prefix di in front of hydrogen. So dihydrogen means 2 hydrogens. Oxygen, since there's only 1, we're going to use the prefix of mono. So we say dihydrogen monoxide, and that tells us that there is 2 hydrogens and 1 oxygen. Now, mono is only going to be used for the second element. Mono does not need to be used if it's used for the first element. The first element, we can understand that it's 1. You don't need to put mono in front of the first element. Okay, so let's try some. So here is our, I made my face big again, sorry guys. All right, so here's our first example, P4S5, and we want to name this. So our first step is we're gonna name this first element. P stands for phosphorus, and I'm gonna give me some room. So P stands for phosphorus, so I'm just gonna write phosphorus. Okay, so here's phosphorus. Then I'm gonna name my second element, which is sulfur. But remember, I'm not going to call it sulfur. I'm going to use the root, sulf, and put ide, I-D-E. Okay, so phosphorus sulfide. However, this is not an ionic compound, so we want to make sure we use these prefixes as well. So 4 is our subscript for P. This stands for 4 phosphoruses. So the prefix for 4 is tetra. So we're going to put tetra in front of phosphorus. 5 represents our sulfur. 5 is penta. So our real name for P4S5 is tetraphosphorus pentasulfide, which is a mouthful, okay? But that is its official name, tetraphosphorus pentasulfide. And all I'm doing is identifying the subscript and putting a prefix in there. Covalent does not switch. So ionic switches, covalent does not. It just, you simply name it for whatever it's listed. Okay, let's try this one. In F3, the first step is we write the first name. First name is nitrogen. And then we name our second element, which is fluoride. But instead of writing fluoride, we're only going to write fluorine. And then we're going to add IDE as our ending. So fluoride, that's our ending. But we're not done yet. N has no subscript. So that means there's only 1 of nitrogen. However, because this is the first element, we do not need to write mononitrogen. It's not necessarily wrong if you were to do that, but we just don't do it. We just leave it as nitrogen. We don't need to call it mono. Okay, that's my husband in the background. His name is Mike. Okay, so sorry. Our third one has 3 fluorines. So the 3 is going to be our prefix for fluoride. So 3 is tri. So we have nitrogen trifluoride. Again, you don't need to put the mono in front of the N. Okay? So that's as simple as naming covalent compounds gets. It's you name it, put IDE on it, and just put the prefixes in. Okay? So now let's take a look at our formulas. So let me just move me back over here. So our formulas pretty much is the same way as the names. Instead of writing the name, we're writing the symbol. So again, we're going to use these prefixes to tell us our subscripts. So our first step is whatever name I give you, you write the symbol of that element first. So if I give you dihydrogen monoxide, hydrogen symbol is H. You write that first. Then you write the symbol of your second element. Oxygen is your second element, so you write the O. Then you're going to use the prefixes, and that's going to tell you how many atoms of each element that you have. And that's going to be that element's subscript. So dihydrogen would give you the subscript of 2, because di means 2. And monoxide means that you have 1. So you don't have to put a subscript there because it's understood. So our dihydrogen monoxide, we get H2O. Again, there is no switching in covalent compounds. You just name it as it is. Prefixes mean for that element. There is no switching. Okay? So let's try some. So the first one we're going to do is antimony tribromide, which quite honestly, you probably don't know what antimony symbol is. So antimony is SB, for those of you still searching on your periodic table. So I'm going to write SB first. And then bromide is BR. Okay, that's bromine. Okay. Antimony does not have a prefix, so we understood that as 1. So we don't need to write a 1 there. But bromine has tri in front of it. That means we need to add a subscript of 3 for bromine. So antimony tribromide is SbBr3. Okay. This next one, my first step is I'm going to identify my first element, which is nitrogen. My second element is chlorine, because chloride is chlorine. So I'm going to write my 2 elements here. Now I'm going to go and add my subscripts. Di means 2. So I know I have a 2 after nitrogen. Tri means 3. So that identifies my formula. Dinitrogen trichloride is really N2Cl3. The prefixes identify what subscript your element has. There is no switching. It's just straightforward name and prefixes. And that's it. That's all you have to do for covalent nomenclature. It's a lot easier than ionic, but it is difficult to keep the 2 straight. So now what you need to do is go into your general channel and check in your assignments. You will see an assignment called Covalent Nomenclature Practice. These are just covalent, so I want you to use what you learned now and go ahead and name and write the formulas for our covalent compounds. If you have any questions or if you get stuck, ask me tomorrow, and then we were going to start mixing up some practice tomorrow. All right, that's it. Go do your assignment. I will see you tomorrow.